Good morning, sir. Myself V. Purnachandra. I am pursuing BTech in the Department of EC, bearing roll number 24BQ1A04I1. Today, I want to tell you a seminar on the topic of sequential circuits. In sequential circuits, I would tell about the flip-flops. Now, I would tell about the flip-flops. A flip-flop is a 1-bit digital memory circuit that is a fundamental building block of sequential circuits. It stores data and it has two stable inputs, and the inputs are 0 and 1. Flip-flops are fundamental building blocks in digital electronics. It serves as a bistable circuit that can store 1 bit of memory information. They have two stable states and are critical for implementing memory elements, data storage, synchronization, and sequential logic in computers and digital systems. Now I would tell about the types of flip-flops. There are 4 types of flip-flops: SR flip-flop, JK flip-flop, D flip-flop, and T flip-flop. The SR flip-flop is also known as RS flip-flop, and the JK flip-flop is also known as KJ flip-flop. Now I would tell about the first flip-flop, the SR flip-flop. The SR flip-flop can be implemented by using two gates, NAND gate and the NOR gates. Now I would tell about the SR flip-flop by using NOR gates. An SR flip-flop can be constructed by using a SR latch made of two cross-coupled NOR gates and two additional AND gates for clock control. Now I would tell about the SR flip-flop by using NAND gate. An SR flip-flop is made by using 4 NAND gates. The two NAND gates are to form a basic cross-coupled latch and two more at the input stage and to add a clock control. The R and S inputs along with the clock pulse are fed into the two input NAND gates. The output of these NAND gates are then fed into the cross-coupled NAND gates, which form the memory element on the flip-flop. The circuit is configured such that the output changes only when the clock signal is active and R and S have a valid input combination. Basic flip-flop, it has two inputs. That the inputs are R and S. It stores data by setting or resetting the input. It has an undefined or invalid state when both R, S and inputs are high simultaneously. It is used for basic memory storage but limited due to the invalid input condition. The SR NAND latch forms the basic of many flip-flops where the inputs determine the output by setting or resetting the stored bit, with feedback maintaining stable output when inputs are active. Edge-triggered flip-flops use additional logic to respond precisely at clock transition rather than being sensitive to input levels at all. Now I would tell about the function table and the excitation table of RS flip-flop. Now we consider that it has two inputs R and S and the next state Qn plus 1. We consider as R and S as 0 0, the next state becomes Qn. Same. Now we consider as R and S as 0 and 1, the output next state becomes 0. We consider S and R as 1 and 0, the output becomes 1. We consider as S and R both are 1 and it is don't care. Now I would tell about the excitation table of the SR flip-flop. In SR flip-flop there are 4 states: Q1, Qn plus 1, S and R. We consider as Qn and Qn plus as 0 0, the SR becomes 0 and the don't care. If we consider as Qn and Qn plus 1 as 0 and 1, then and the S and R becomes 1 and 0. We consider Qn and Qn plus R 1 and 0, the S and R becomes 1 and 0. We consider as Qn and Qn plus 1 both are 1, the S and R becomes don't care and the 0. Now I would tell about the second type of flip-flop named as JK flip-flop. The JK flip-flop is an advanced sequential logic circuit that overcomes limitations of the basic SR flip-flop by eliminating invalid states and adding toggling capability. It has two inputs J and K along with a clock input, and it has two outputs. The JK flip-flop is a fundamental type of sequential logic circuit and digital memory device that is used to store a single bit of binary data. It is an improvement over the SR flip-flop because it eliminates the problematic invalid or indeterminate output state that occurs when both inputs are high. The J and K inputs acts as the set and reset signal respectively. The JK flip-flop operates based on the combination of inputs J and K during a clock pulse, typically on the rising edge. When J equal to 0 and K equal to 0, the flip-flop holds or retains its previous state. It does not change. When J equal to 1 and K equal to 0, the output becomes q equal to 1. When j equal to 0 and k equal to 1, it resets the output and q becomes 0. When j equal to 1 and k equal to 1, the output toggles, it flips from 0 to 1 or 1 to 0 with each clock pulse. The JK flip-flop avoids the invalid state that occurs in the SR flip-flop when both inputs are high. It is widely used in counters, shift registers and toggling applications due to its toggle operation. The master-slave JK flip-flop configuration uses two flip-flops to prevent race-around conditions and produce stable output by triggering and opposite clock clutches. The flip-flop is edge-triggered, meaning it changes state only at a clock transition, which helps synchronize digital circuits. Now I would tell about the third flip-flop, named as D flip-flop. The D flip-flop, also known as the data or delay flip-flop, is a fundamental memory element in digital electronics that captures and stores a single bit of data. It has two main inputs, the data input D and the clock pulse input CLK. When the clock signal transitions, the flip-flop captures the value present at the D input and holds this value steady at output until the next clock edge. A D flip-flop is a digital circuit that stores a single bit of data. It is also known as a delay flip-flop because it delays the input data until the next clock pulse arrives. The flip-flop has a data D and input clock pulse, and it has two outputs, Q and its complement Q bar. The output Q takes the value of the D input and the clock signal transition from low to high and holds that the value until the next active clock edge. Now I would tell about the truth table of the D flip-flop. If Q equal to 0 and D equal to 0, the next state becomes 0. If Q equal to 0 and the D equal to 1, the next state becomes 1. If Q equal to 1 and the D equal to 0, the next state Qn plus 1 becomes 0. If Q equal to 1 and D equal to 1, the next state becomes a reset state, and it means 1. The D flip-flop solves the problem of undefined states in SR flip-flops by ensuring that the inputs are never in a contradictory state since it has only one data input. It is often used in shift registers and other sequential logic applications where precise timing and storage of binary data. The D flip-flop is a clock latch that samples the input data on the clock edge and holds it stable until the next clock signal, making it an essential building block for timing and data storage in digital systems. The D flip-flop ensures the changes in the output are only reflected in the output at specific clock instances, avoiding any instability or glitches due to input changes at other times. The output Q follows the input D at the moment at the clock edge and remains constant in between. This makes the D flip-flop remains constant in between. The D flip-flop very useful for synchronized data, creating registers, counters, and for memory storage in digital circuit. Now I would tell about the last type of flip-flop named as T flip-flop. The T flip-flop, also known as the toggle flip-flop, is a type of flip-flop that changes its output states on each clock pulse when the T input is high. It is essentially a modified JK flip-flop when the J and K inputs are connected together to form a single input called T. When T equal to 0, the flip-flop remains its current state. It does not change. When T equal to 1, the flip-flop toggles its output, changing from 0 to 1 or 1 to 0 with each other clock pulse. A T flip-flop is a clocked digital circuit that toggles its output due to the opposite state. When the T input is 1, it holds its current state when the T input is 0. The T stands for toggle and it is often used in counters and control circuit. The toggling property makes the T flip useful in frequency division, counters and toggle switches. It can halve the frequency of the clock signal by toggling its output every clock pulse, effectively dividing the frequency of the two. The T flip-flop is crucial in digital electronics for its stability to toggle output states, making it ideal for counters and frequency division applications. Now I would tell about the truth table of the T input. When T equal to 0 and the present state equal to 0, the next state will becomes also 0. When T equal to 0 and the present state equal to 1 and the next state becomes 1. If T equal to 1 and the present state becomes 0, then the next state becomes 1. If T and the present state both are 1, then the next state becomes 0. Now I would tell about the key applications of the flip-flops. The flip-flops are widely used in counters, frequency dividers, storage registers, shift registers. Flip-flops are used extensively in digital counters that count pulses or events. JK and T flip-flops are commonly used in the ripple and synchronous counters. This device sequentially moves through states to represent counting numbers. Flip-flops divide an input clock pulse by factors toggling their output states on clock pulses. This is essential for clock generation, circuit, and timing applications. It is used to hold data temporarily in computers and digital devices. D flip-flops are typically arranged in groups to form registers that store multiple bits of data synchronously. It consists of cascaded flip-flops that shift data serially, enabling data conversion between serial and parallel forms, useful for data transfer, communication systems, and digital signal processing. The flip-flops serve as a fundamental digital memory elements and timing synchronizes integral to counters, dividers, registers, and various control and storage functions in the electronic system. This is the topic about the switch flip-flops. Thank you.